Want to finish up with this last piece here. Important to start thinking about the consequences of measurement, error, reliability types of stuff within the context of our multiplicative models. We start to see measurement error when we have measures that start to have poor reliability, either sort of poor internal consistency, poor retest reliability. You know, if we're working with new measures that, you know, we're just generated, and sometimes we need to do that because no one's measured this before, and so we have to develop our own stuff. But the concern is always that sort of what is the reliability of my measure, and the more sort of error static stuff that we start to go in, thinking about the consequences the practical consequence that has on our models. Now remember, a primary assumption of our regression analyses is that our X variables, our predictors, are measured without error, right? Fundamentally what we say is we're assuming that all of the inputs into our model, all of our predictors, are measured perfectly. That doesn't happen. Now if it's, we could do a pretty good job, our models are okay, but as that error variance starts to increase, starts to create a lot of static in our model. We're talking about our bivariate analyses, right? Our Pearson correlations, our bivariate regressions, our error in our predictors will attenuate the estimate of our association. It's going to, the observed association we get is going to be lower than the population estimate, okay? Because if this is, if this is my population correlation, right? What I'm going to get here is sort of whatever my observed is times my reliability, right? And in this case, what's the max reliability coefficient we can have? If I have perfect reliability, it's going to be 1, right? If I have less than perfect reliability, what's the value going to be? Less than 1. And if I start multiplying something by a number that's less than 1, what happens here? It starts to go down, right? And so this is what happens when we start to, in the bivariate case, if we have error in our analyses, it's going to attenuate our estimates. Our estimates are going to be smaller. They're going to underestimate the population coefficient. If I have multivariate in our multivariate analyses, multivariate regressions, things start to get more complicated. In general, sort of extent bias depends on how our scores are all intercorrelated with one another, but it's problematic in that it starts to screw with our population estimates based on the data that we've collected. And specifically when we're talking about our interaction terms, right? Remember that what we've done in creating our interactions, we've taken sort of variable 1 and variable 2 and multiplied those two things to provide our interaction effect. What ends up happening is that the reliability of our interaction term, right? So I've gone through and I've multiplied, pain and PTSD, that was something we used, looked at that interaction effect there, right? Well, I've gone through and I've measured pain severity with less than perfect reliability. I've measured PTSD with less than perfect reliability. And when I multiply those two scores together, the reliability of my interaction term is now a function of the reliability of X and the reliability of my moderator, okay? And so what ends up happening is that if my reliability of X is less than 1 and my reliability of my moderator is less than 1, what's the resulting reliability of my interaction term? So it's a lot smaller, right? If I take 0.5 and I multiply it by 0.5, what do I get? 0.25, right? That's a huge reduction, okay? Now, this reliability of this interaction starts to increase marginally if, to the extent that X and M are correlated with one another. So if my conditional effect and my interaction and my moderator are strongly correlated, that helps this to some extent. But at the end of the day, we can think about our interaction terms, the reliability of those interactions as being roughly the product of the reliability of my two base variables. Okay? And so what ends up happening is we get dramatic reductions in the reliability of our interaction effects when we are measuring our inputs with less than perfect reliability. And this starts to get really, really bad, okay? If we're thinking about effect sizes in their relation to power, our F squared and our squared partial correlations, these are direct indices of statistical power. If we're running a power analysis for regression, these are, and again, F squared and squared partial correlation have direct relations with one another, right? So these are the effect sizes that we would go through and enter for our power analyses. Our squared semi-partial correlations, these are useful. They contain sort of an intuitive meaning, but don't hold a linear association with power, and so we can't, these aren't useful for power analyses. It's nice just kind of a descriptive metric of proportion of variability and total variability accounted for, but what we're wanting to look at in terms of our power analyses is our F squared or our partial correlation, okay? And what we find here is that if I'm, let's say, I have an effect size for my interaction term, okay? My effect size for my interaction term accounts for 1% of the variability in Y, okay? When my, so let's say section 3 right here, that represents 1% of the total variability in Y, right? So what's my squared semi-partial correlation going to be? 0.01, right? Well, what happens to my partial correlation in my F, depending on how much variability the rest of my variables are accounting for, that starts to have a huge impact on my partial correlation or my F squared, okay? Because remember that my partial correlation is the proportion of residual variability in Y shared with X, okay? And so let's say that I have area 3 accounts for 1% of the variability in Y, okay? But let's say that my other predictors, everything else in the model accounts for 80% of the variability in the rest of the stuff, right? So what do I have if my predictors, if my other variables are accounting for 80% of the variability, what's left over? Right? And so I've got 0.2 plus 0.01, right? Someone tell me what my partial correlation is. What is it, Emilio? 0.047. Okay. So this is going to be my my squared partial correlation. So I'd say about 4.7% of the residual variability is attributable to sort of X, right? But what if I have a situation where, and so this is good, right? So I've got a predictor, but the other variables in my model are accounting for a big chunk of what else is going on in the model, right? So I've got a really good model. Essentially, in this case, my R squared is going to be 0.81, right? But let's say we got a different scenario. X1 is still accounting for 0.01% of the 1% of the total variability in Y, right? But this time, my other predictors are only accounting for 10% of the variability, right? In this case, I've got 0.90 plus 0.01. What's my squared semi-partial now?
.011.
0.011. Okay. Here, my R squared is, right? So my effect size, my partial correlation here, same situation, right? And in both of these scenarios, my squared semi-partial correlation is still 1%, right? So I would say the proportion of total variability in Y uniquely attributable to X is 1% of variability, total variability in Y. So in both of these, my semi-partial correlation hasn't changed, but my partial correlation goes from 0.01 if I've accounted for 11% of the variability. Same sort of region right here, and jumps up to close to 0.05 if I've done a good job of accounting for total variability, right? And so what we see is that our squared semi-partial correlation doesn't give us a good sense for relating to power, but my partial correlation and my F squared, same thing with F here, is going to be hugely dependent. So the magnitude of this effect size, which we can use as a metric of large or small, medium, large effect, is going to depend hugely on how much of the total variability my outcome is accounted for, right? My power jumps up, or the size of my effect jumps up huge, the better my model is for accounting for other stuff, okay? People see what's going on with this, okay? So again, with 80% of the variance explained, 1% increase in the residual variance gives me an F of 0.05 with only 10% of the variability, right? 1% increase is an F of 0.01, right? So we've got an effect size that's 5 times that, even though area 3 stays the same across these, just based on how much of the other stuff that's being accounted for. So the take-home message here is, outside of, this is why we look at these metrics for power, not squared semi-partials, is that if I'm trying to get a well-powered regression model, it's in my best interest to try and account for as much of the total variability in my outcome as possible. That's going to reduce my error term, because everything up here, everything that I'm not accounting for goes into my error term. If I'm accounting for more variability in my outcome, I have less overall variability in my model. I have more power to test the effects that I want to be testing. Okay. And now, trying to account for total variability in your outcome doesn't mean just throwing a bunch of stuff that's overlapping with one another, because that's going to screw you over. But to the extent that I can find variables that are relatively unrelated to one another, that start to account for different pieces and parts of what I'm trying to account for, that's going to be your best and most powerful models that you can go through and put together. So, always want to establish a model where your first order effects are accounting for maximum variability in your outcome, so long as those predictors aren't all correlated 0.9 with one another. Okay. So if we're thinking about interpretive norms for small, medium, large effects, for our F squared, small, medium, and large in terms of interpretive benchmarks for F squared, and here, you know, I harp on you guys not sort of adhering to benchmarks, but F squared doesn't have a good interpretive value, or a good conceptual interpretation outside of just telling me exactly what goes into F squared. So in general, thinking about these in terms of small, medium, large, same thing, your squared partial correlations kind of have some interpretive value. Think about this as the proportion of residual variability attributable to a predictor in a model. But again, thinking about small, medium, and large effects here. These being nice things to report within the context of your regression models. You're doing people down the road a solid, right? John, someone down the road 10 years from now wants to replicate your thesis. They're trying to determine how many people they should maybe think about needing in order to determine effects. These are going to be nice for them to have, because it's going to be hard to calculate it otherwise, right? So wanting to go through and have that information available. Okay. People seeing the relation between effect size, power, things like this. Okay. So to bring it home, this is just an example straight out of Bacon and West. If we assume that we have a case where my conditional effect and my moderator are uncorrelated with one another, right? And my lower order effects are accounting for 50% of the variability in my outcome. Okay, so my R squared here is if I'm doing this as structuring this as a higher order model, sort of my lower order effects are accounting for 50% of the variability in my outcome, which is outstanding, right? What we can do is we can start looking at the sample size I need to achieve power equals 0.08 or 0.80 for small, medium, and large effects. Okay, so we've got a scenario where my first order effects are accounting for about half the variability in my outcome. And what I want to know is how many people do I need to have in order to test my moderating effects, because that's what I'm really interested in, right? I'm interested in powering these interaction effects, right? If I'm looking for a large effect, right? So I've been looking at an F of 0.35, okay? So I have some reason to believe or have evidence that this interaction is consistent with a large effect. The interaction term I'm looking for consistent with a large effect. F squared equal 0.35. If I've measured X and my conditional variable for my conditional effect X and my moderator at perfect reliability, such that the interaction of my interaction term has perfect reliability, reliability 1, with an F squared of 0.35, I need 26 people in my model to adequately power that, the test of that interaction. Okay? But let's say that I have the reliability of my interaction term isn't perfect, but it's 0.8. 0.8 is pretty good, right? If I'm going through looking at a study and it says reliability of this measure is 0.8, I'm like, okay, that's pretty good, right? What ends up happening is the effect that I'm actually looking for, if it's large, drops down to 0.11, right? The functional effect that I'm trying to get at because of the decrease in my reliability, and my sample now jumps up from 26 to 75 just because the reliability of my interaction term is decreased. If my reliability of my interaction term drops down to 0.7, my functional F that I'm looking for is 0.06. Now I need 127 people, right? So with perfect reliability, I've gone from a projected sample of 26 to less than perfect reliability, but still within the bounds of something we would call adequate, is now 5 times as high. Right? I'm looking for a medium effect. It's a population effect I'm hunting as a medium effect, right? Perfect reliability, the effect I'm looking for is actually reflective of the population. The observed effect is equal to the population effect. Need 55 to adequately power the test of this interaction. If my reliability of my interaction drops down to 0.8, so the observed effect I'm looking for it actually drops down to 0.05. Need 153, down to 0.7. I now need 257 people in order to adequately power my test. If I'm looking for a small effect, and this is where our interaction terms live. Our interaction effects are generally small effects. They're subtle stuff. If I measure my predictor and my moderator with perfect reliability, I'm looking for this F, this interaction, the effect size of 0.02. I need close to 400 people to adequately power this test of my moderation. If that moderation effect is small in the population. If I go down to 0.08, I need over 1,000. So 0.7, now I'm getting close to 2,000 people, right? So you start to see how much of an impact. And so we can think about, reliability. Who wants to do nerd stuff and check out the psychometrics of my measures? It's fine. Or I just want to measure this, so I'll just put together a couple items and things like that. The practical consequences for your actual tests are massive. Okay. We don't think about this a whole lot. It's a methods issue, it's not a statistical issue. And we say, oh, everybody uses this measure, and because everybody else does it, I'm just going to go through and do it. Wanting to think about, to get to this point, to get to an interaction term that has a reliability of 0.8, you need reliabilities of 0.89 for both your X and your moderator, right? I need outstanding reliability for my X and for my moderator just to get the reliability of my interaction term to 0.8, right? If I have 2 variables, my 2 variables have reliability coefficients of 0.8, excellent reliability. What's the reliability of my interaction term in that situation? What's 0.8 times 0.0? What's 0.8 times 0.8? 0.64, right? My interaction is less than sort of, it's terrible, right? The reliability of my interaction with two measures that have good reliability, when I multiply them together, the reliability of my interaction gets really bad. And so now what I've done is I've attenuated sort of this effect size that I'm looking for. It ends up being terrible, right? So thinking about this in terms of being very, very careful in the selection of your measures, making sure that those measures are administered reliably, because to the extent that our measures start to be less than perfect, it has a massive impact on sort of our power to test these effects that we're trying to get at. So some method stuff that starts to directly impact our analyses. Questions about this? All right. Some advanced stuff. Aiken and West does an amazing job of sort of getting into some more complex types of things that you can do with these moderation analyses. Would strongly encourage you to go through, take a look at some of these chapters if you're starting to work with projects that are looking at moderation stuff. So again, bringing it home, we're thinking about moderation, right? We're talking about some process where we've got a third variable changing the nature of the relation between X and Y. Want to go through center our variables or center our regression models. It's going to improve our interpretability. We can go through, change our analyses around to go through and get appropriate standardized effects. We can go through, we can get categorical predictors. Remember, in presence of a multiplicative effect, if I've got a significant interaction, I no longer have main effects, I have conditional effects in the presence of that significant moderator, right? The relation between X and Y is dependent on the value of some third outcome. And as I'm going through, as I start to get into these interactive models, all of a sudden measurement error starts to become a huge, huge issue because it's going to screw over my power to detect my moderation effects. Also, as we're going through and screening, our analyses tend to be pretty robust if we've got large effect sizes to high leverages, high influence values, and things along those lines. Unless they're way off in the distance, as long as we got decent sample size, we can probably tolerate most of that stuff. But as soon as we get down into our interaction effects, one screwy case can completely sort of swamp or create an interactive effect that will never ever replicate in anybody else, because you've got Layla, who's a weirdo case that's causing this interaction term to be statistically significant. Layla's never going to be in any other sample that's ever collected again in the universe, but now I've published a paper that is with an effect that's basically based on Layla, right? And so when we're going through and we're screening for our multiplicative models, wanting to be sort of super vigilant to things that might go through and tweak with stuff. And again, best case scenario there, if you get something that looks squirrely at all, run your model with and without that case, make sure that everything stays consistent. If it's consistent, then just leave it in, right? We want to have the threshold for throwing people out to be pretty high. But if all of a sudden an interaction term appears or disappears based on whether or not Haley and Evelina are in the model, that's not a good thing to be reporting on, because it's not something that's going to generalize and be consistent. Questions on any of this? Okay. Awesome. All right. Who's ready for something that's a little less heavy? Nice thing about this stuff is that mediation analyses from the perspective of sort of an analytical work is much, much more straightforward than all the stuff that we've been working with in our moderation models. Again, we started out a few classes back talking about, you know, after a while, to what extent are our just first order regression models interesting, right? How many times can I find that X is uniquely related to Y before that starts to get old and boring, right? Are basic regression models helpful in that they give us a sense of the unique relation between X and Y? But again, not really limited in what they can tell us about sort of what's going on in this association, right? To what extent are X and Y associated with one another? And again, if I've gone through, and there's been study after study after study after study that suggested that X is related to Y, it's no longer interesting to continue to demonstrate that. We already know that, right? But what might be an interesting step is to say, why? Why are X and Y related to one another? What are the things, what are the underlying mechanisms? What causes X to be related to Y? And if we're interested in why, sort of what types of factors account for, sort of maybe even start to cause, we don't talk about this in psychology. So I dare you to try and say X causes Y in a paper and see how far that gets you with a reviewer, right? Might be a little too intense about that. But we can talk about plausible and theoretical explanatory variables and things like that. That might be an interesting thing to start asking. Why do we see that this variable is related to that outcome, right? And if we do this, what we're talking about is a mediator, okay? If we're talking about mediation, we're talking about a situation where some sort of thing is causing or facilitating this association between a primary X and our outcome variable, okay? And within the context of sort of this conceptual model, our mediator is going to be anything that accounts for this relation between X and the relation between Y. So if we're going through and we're talking into or we're graphing our mediation out, this is often how we'll turn it weird, often how we'll go through and graphically represent this. We're saying that X is related to Y, right? We all know that X is related to Y, but what's really going on is we've got this third variable. We've got this mediator that's going through, and what's actually happening, the reason that X is related to Y is because X is causing this mediator is then causing Y. And if we account for this mediator, what happens to the relation between X and Y? It goes away, right? X is not related to Y once we account for this mediator, because this is the reason these two variables are associated with one another in the first place, right? So I talked with, in my intro class, we were talking about spurious correlations, right? I find that pavement temperature is associated with drowning, right? So the heat of the average heat of the pavement in a given day associated with drowning deaths in this community, okay? And so in that class, so do we need to just keep the roads all iced down so no one drowns? Obviously not, right? What's going on? How do we account for this association? What's going on? Okay.
When it's hot outside, well, it's just hot outside, so
yeah.
people are going.
Exactly, right? So in this case, we have a correlation between pavement temperature and drowning deaths, right? But if we account for season, right? People don't go swimming in the wintertime for the most part, right? If we account for this, if we account for sort of type of season we're talking about, is pavement temperature related to drowning deaths at all anymore? Nope, because this is the mediator. This is the causal variable that's creating this association right here, right? This is different than our moderation, right? Within the context of we're talking about a moderator, we're talking about in a moderation analysis, we're talking about what are the boundary conditions. X is related to Y. But is X related to Y in the same way for always and forever under all possible circumstances? Or are there certain things that start to change the magnitude or direction of the relation between X and Y? So if we're talking about our moderator, we're talking about something that changes the nature of this relation. Our mediator, we're talking about the mechanism. How do we explain this relation or this association between X and Y? Okay. So we could say in our mediation example that association between attitudes and behavior is mediated by behavioral intention, right? So you guys do this in Ben's lab, right? Social psych stuff. Sean does some of this stuff, right? So this idea that my attitude and my behavior is mediated by sort of my intention to engage in certain types of behavior. That's why these two things are related. If I account for that, then there's no relation between attitudes and behavior unless I intend to act on that, right? So we're talking about behavioral intention as the mediator in this situation. From my field, right, we've got EMDR, eye movement desensitization, reorganization, something. Who knows what they're talking about these days. But basically, if I go through and you wave my finger around, you watch it while you're talking about your trauma, you get better, right? And we know this works, right? But what I would say is probably that positive effects of the relation between treatment and outcome is mediated by exposure stuff, not by screwing your eyes around, right? This is the thing that's accounting for this relation, this effect right here. And so these are going to be questions about mediation. What are the mechanisms underlying that are causing sort of this stuff to go on? Okay. Questions about the difference between our mediators and our moderators. Both of these are very good questions and approaches to developing papers, publications, theses, dissertations, things along these lines, right? Because again, what we're doing is we say, with both of these situations, we're saying, we know that X and Y are related, why are they related, right? Or we know that X and Y are related, what are the conditions under which that association holds? These are nice ways to go through and start thinking about some of the phenomena that we're interested in more nuanced ways, but wanting to make sure that you're not calling mediators, moderators, moderators, mediators. People do this all the time. You just want to make sure that you're conceptually clear on which one of these you're talking about. So, testing mediation. How do we go through and test these mediation models? Testing them is easy. Collecting data that provides a compelling case for it is considerably more difficult. But if we go back through a seminal article by Judd and Kenny, a couple different papers. Judd and Kenny came up with what's classically termed now as a causal steps approach to mediation. And what Judd and Kenny argued for, in order to determine or establish a mediated effect, what we need to have is we need to have a situation where X is related to Y. So my independent variable has some relation with my outcome variable, okay? First step, need to have a relation between X and Y, because if we don't have a relation between X and Y, there's no reason to talk about mediation, because there's no relation there to mediate, right? So number one, we need to establish a relation between X and Y. This is gonna be our path C right here, okay? And then what we need to say verifies that each variable in the causal chain impacts the variable that follows it when all the prior variables are controlled for. So we need to establish that X is related to our mediator here, right? Then we need to establish that my outcome is impacted by my mediator controlling for this initial X, right? So everything to the left of this path needs to be accounted for. Here, when I'm looking at my relation with my mediator, the only thing to my left is X, right? So I don't have to worry about X. When I'm looking at the effect of Y, I not only have to worry about establishing a relation with my mediator, or with my mediator here, I also need to make sure that my X variable is included there to account for that stuff, right? And then within the causal model is if I identify a relation between X and my mediator, path A, and I identify a relation between my mediator and my outcome, controlling for X, then X now no longer demonstrates an association with Y once I've accounted for the mediator in the model. This is going to be my C cry path, okay? So X is related to Y, just in the bivariate case, and we've got that X is related to the mediator, and that the mediator is related to my outcome when I control for X, and then once I go through and I control for that, my mediator, this C path goes away. Right? It's no longer statistically significant. And for Judd and Kenny's causal steps approach, this would be how we go through and establish a mediated effect. This relation between X and Y that we've seen, it goes away once we've accounted for our mediator. And if X is related to our mediator and our mediator is related to our outcome, once we've controlling for X, and now X is no longer related to Y, classically we would say that this is, we've established causal step stuff. Are people getting the idea behind this causal steps approach? All right. Barron and Kenny then had an influential paper that goes through and sort of tweaked this just a little bit, okay? Barron and Kenny sort of loosened things up a little bit, and what Barron and Kenny, their alteration of the causal steps approach is saying, yeah, what we want to have is we want to have a relation between X and Y. There has to be an association there to mediate, otherwise why are we talking about mediator, right? Again, my mood today and eye color in China aren't related probably, so no reason to look at a mediator for that association, right? So we need to have an association there, and then we need to demonstrate that X has an association with my mediator. Why is this important? Why do I need to demonstrate that X has a relation with my mediator? Conceptually.
Does that mean you show there's like a causal chain, there's no relation? One of the variables in the mediator.
Yeah, if I'm saying that X and Y are related because X causes the mediator, the mediator causes the outcome, but I can't establish that X is related to the mediator, then all of a sudden everything starts to fall apart. It doesn't make any sense, right? So we need to make sure that X is associated with my mediator, and then that my mediator holds a significant relation with my outcome, right? But then this is where they tweak things a little bit, right? In Judd and Kenny's original conceptualization, they say that this C path that was statistically reliable has to go away. It's no longer statistically significant. Barron and Kenny say, well, once we've controlled for A and B, what we see is that C doesn't have to go away completely, it just needs to be significantly reduced. We need to see some reduction in the strength of the association between X and Y. Strongest evidence for mediation is if C path goes away completely, right? But what they've done is loosen this up a little bit to say C doesn't have to go completely away, but what we need to do is we need to demonstrate some significant reduction in the strength of this path. And if we can do that, then we can go through and still claim some evidence for some degree of mediation within these analyses, okay? So assumptions in these causal models. Causal model approach assumes that X is a cause of Y and not vice versa, okay? I need to go through and be able to establish that either have a strong empirical or theoretical argument that X is the thing that's driving Y as opposed to the opposite way around, right? We can't say that Y, because if I just say that X and Y are correlated, well, I don't know, maybe X is causing Y, maybe Y is causing X, I don't know, just sort of where I'm putting things in. I have to have a good argument that X is causing, this is something that's happening that's driving my outcome. We're also assuming that my mediator here is preceding Y in time, and that my mediator is a plausible agent in my outcome. Okay, so a couple things here. I need to say that the measurement of Y, my measurement of the mediator is happening in some point in time before I've measured my outcome. Okay, this starts to establish a temporal precedence for mediator, right? Because my Y can't go back in time and sort of influence my mediator if I measure Y a year from now and a mediator today, right? So we need to have mediators, my mediator, one preceding Y in terms of sort of in our sort of linear path down time, and then our mediator has to be some plausible agent of Y. Mediator has to be, theoretically, I have to have some good argument that yes, this variable causes changes in my outcome, right? My mediator can't just be whatever, right? So my mediator is space aliens, right? And so that's what's going through, like that isn't making sense, right? So conceptually, it's incumbent on me to explain why, and then what we're assuming is that the relation between X and Y is not the product of some unmeasured construct or process. Basically, we're saying that whatever is going on here isn't something that's outside of our model that we haven't captured in this process. This is really important. People understand the logic of sort of this statistical model, the progression of logic that's sort of underlying this causal steps approach. Questions? Okay. So, Barron and Kenny's reformulation about this. So what they do is they start to recognize here cases of what we might call partial mediation. So we're not saying, as opposed to the original Judd and Kenny formulation, where this original relation between X and Y has to go away completely, right? This is like, those of you in experimental stuff, right? Like a lot of, God bless you guys, talking with Sean and Ben about what it takes to get a goddamn paper published without sort of absent 50 different studies on stuff. But a lot of it sounds like what you guys are asked to do is, okay, you've developed it, you've demonstrated association, make it go away, right? Make it go away, and then that will convince us that what you're doing is actually real. But that's a lie. It's like in football practice, like, oh, one more line, and then it's 10 more lines, and you're mad, right? But this is kind of this idea that if we go through and account for this thing, this association goes away, because this is the mediator, right? Barron and Kenny say, well, it doesn't have to go away completely, but we just need to see some significant reduction in this outcome, right? And so what we would refer to this, even if my C prime path is still statistically significant to some extent, we might call this, we might claim evidence of partial mediation. And if we think about how our psychological constructs sort of put together, this idea of partial mediation seems more plausible, given, and I can't even think about a case where just one mechanism, one thing accounts for the relation between X and Y, right? Try and think about some psychological process, some association between two reasonable variables where it's one thing that accounts for all the variability. There's one causal mechanism, right? So, Bailey, if I'm looking at sort of thoughts on sort of juror perceptions of guilt, right? There's probably 1,000 different things going there, right? I can't have 1,000 different things in my model, right? I want to maybe get a couple of big things, but what it might not be reasonable to expect that if I account for this one thing that I really do think could be a causal factor in determining sort of this relation, that it's going to account for all the variability in that, right? And so probably what's going to happen is I might see a reduction in the relation between X and Y, but it's probably not going to go away, right? And so again, as we start to change things up from sort of this really hard and fast, we need to see this base association disappear completely, to Barron and Kenny's formulation, it doesn't have to go away completely, we just need to see a significant reduction here. Starts to probably become a better representation of the types of things that we study, right? Things that we can see maybe start going on contributing to partial mediation. X has both a direct effect on Y and an indirect effect through my mediator. So, if I'm saying X what I'm saying here is that in the case of partial mediation, what I might get is that, yes, what ends up happening is there's part of X that's driving this mediator, and that mediator is then driving variability in Y. But X might have just a X alone might have a causal influence on Y just in and of itself, right? So we've got a complex situation here where X has both a direct effect and an indirect effect through the mediator, right? In this case, even if we account for the mediator, if there's something in X that still is driving, some part of X is still having a direct relation on Y, we would still expect to see an association here. It's going to be less, right? But it's still going to be present. So we could have X with having both a direct and an indirect effect on Y. We also might see that the relation between X and Y is mediated by several processes or constructs. There's a lot of mechanisms, right? There's a lot of things, right? And so what might happen is, yes, even though this is a mediator of this relation, there's other stuff going on that I haven't included in my model, and so I still get a relation between X and Y. Now this is problematic is because technically this is a model method. This would represent a misspecified model. Remember, one of our underlying assumptions of regression is that all the variables that need to be in there are in there, and those that aren't, right? So technically, I could get partial mediation due to misspecification of the model, and that's problematic because it could bias results, right? We conveniently ignore this, but this is a big deal, right? So if I think there are multiple mediators within this situation, I should probably be trying to account for them, but we could have a case where I have a couple of relevant mediators, but there's still other ones that I didn't or couldn't capture, and so those are still driving my residual effect here. I could have a situation where my indirect effect of X on Y through my mediator isn't the same for all my members of the population, right? So for some people, let's say, I'll pick on you, it's not picking on you, you did a fantastic job the other day in your proposal, right? So we were saying that people who sort of might have sort of eating disorder processes and outcome, right? And so we've got this mediator and this thing, but maybe sort of the action as a mediator is different for some people in my group versus others, right? There could be, depending on the specific type of eating pathology, sort of this, for some people, this indirect effect through my mediator is quite strong, but for other people it's not there at all. And so what I might find is I still get a residual effect here, even after I've counted for my mediator, because this indirect effect of AB, right? My indirect effect isn't the same for everybody, okay? And if this is the case, what we've got is we've got a model misspecification because we're missing things in the model. Technically, what we're talking about is a moderated mediation, right? If there's some now fourth variable that changes the strength of this indirect effect, this AB effect, what we've got is a moderator that's moderating our indirect effect. And so now we've got moderated mediation that's resulting in a continual relation between X and Y. Again, this is going to be a model misspecification, but it's something that could go on, right? We also might see measurement error in my mediator results in underestimation of its relation to both X and Y, okay? Basically, I've got a mediator, it's a new construct, no one's got a good measure of it, so I just kind of make up my own, do the best that I can, but I've got a lot of measurement error, so that attenuates this association, attenuates that association, and so I've still got a residual association right there because of error variance in my model right there. Again, this is another case of model misspecification because I've not measured my predictors with perfect reliability, and so they've got weird stuff going on there, right? But because of any one of these situations, I might start to find that I continue to have a residual relation between X and Y even after I've accounted for my mediating variable here. Okay? So what we're concerned is what happens to this base path once I include my mediator. Judd and Kenny said that this thing has to go away completely. Barron and Kenny said, well, that would be nice, and that gives us strong evidence for a mediated effect, but in actual fact, there's a lot of things that might contribute to that C prime path continuing to be present, even though we've accounted for something that might be a plausible mediator. Okay. Questions? All right. All right. Let's take a quick break, and then we'll jump into our causal step stuff. Yeah, run, do stuff, and then we'll jump into here. Okay. You're gonna love this. You're gonna be so excited about this. It's gonna feel intense joy as we're working through our analyses for our basic mediation models. Okay, it'll be so much easier than the stuff that we're working on with moderation. So basically, what I need to do for a basic causal steps approach, first thing I need to do, regress X onto Y to establish that there is an effect to be mediated. Okay, this is my test of path C. Okay, so go through center stuff, regress X onto Y, get my path C. It says X and Y are related to one another.
X onto Y or Y onto X?
Or excuse me, Y onto X, right? We talk about, we regress our outcomes onto our predictors. So regressing Y onto X to demonstrate that this is actually, does it make a difference? Is it simple mediation? No. No, it is. No. You're just guessing, right? It was one or the other. No, I mean, basically, essentially what we're doing, we got correlation here, and I mean, it's just two variables right now. As our models get more complex, then that starts to be a different issue. But we just going through, first step, we regress Y onto X to establish that there's a relation to there to be mediated, okay? Number two, we regress our mediator onto our predictor, demonstrate a relation between our mediator and predictor. So model one, regressing Y onto X, cool. Model two, we regress our mediator onto our X to establish a relation right here. Right? Three, we go through and take our Y, we regress it onto both our mediator and our X value to establish this unique relation between our outcome and our mediator, path B, above and beyond sort of the stuff that's already going through right there, right? Because and what we don't want to do is not, we can't just regress Y onto our mediator to get B, because what we're doing is we need to go through and remember account for everything to the left of our model here, right? So I need to establish that my mediator holds a unique relation with my outcome even when I'm controlling for that initial X variable there, right? And so I have to account for my original X variable when I'm measuring my effect right there. And so then what I do within that model is determine whether or not my mediating variable completely accounts for the relation between X and Y through my test of C prime right here, right? And so first thing I do, I regress Y onto X, that's model one. And I regress my mediator onto X, I get path A. And then in my last model, I regress Y on a mediator in my X. One of my predictors, my coefficient for my mediator is going to give me path B. My coefficient for X in that final model is going to give me my C prime. This is my residual, right? And what I want to do is see what this, what the effect of C prime is. If C prime is not significant, then I say claim full mediation, right? It's gone from something that was statistically significant, now it's not statistically significant, we say full mediation. But even if I still have a residual association, even if X continues to hold a unique relation with my outcome, even after accounting for my mediator, what I might have here is I might be able to make a claim for partial mediation, okay? And this is where things get a little bit tricky, okay? What I'm hoping to do through this series of causal steps is I'm hoping to get, and remember Barron and Kenny are saying what we need is a significant reduction in C to C prime. Right? The difference between C to C prime has to have some sort of significant change in order to claim partial mediation. So I need to say that C minus C prime is some significant value. okay? And if it is, then I would say, okay, I've got partial mediation. If it's not statistically significant, I can say, well, looks like X shares some relation with Y, and so we just see a reduction, and so that's just kind of what we would expect within the context of these models, right? And so my measure of my indirect effect right here, I can represent this in a couple of different ways. I can think of my indirect effect as the product of my A and my B paths, okay? So I can take path A, multiply it by path B, and that gives me AB, and talking about this as this indirect effect. Or I can talk about my partial mediation as a function of the reduction of C to C prime. Mathematically, this coefficient and this coefficient are equal to one another. They're the same number. You'll see this, right? What this ends up being is sort of more of a semantic issue. Am I thinking about the extent to which accounting for this mediator reduces the relation, the observed relation between X and Y? Or do I want to think about this in terms of an indirect effect, the product of path A and the product of path B? Okay? But mathematically, they're the same. They're interchangeable. Okay? So it doesn't matter whether or not I'm talking about AB or the difference in C to C prime. It's the same number, it's the same quantity, it's the same amount. I like to think about things in terms of the indirect effect, AB, because it's just an easier way to think about things. It's more flexible when we start to add additional mediators and things like that in the model. Thinking about things as indirect paths within the context of path analyses starts to make more sense. But originally, in the sort of original 80s conceptualization, we're often talking about this as a reduction of C to C prime. Now, the total effect of X on Y is going to be the sum of all our direct and indirect pathways, right? So in this case, C so here we've got AB is equal to C minus C prime, right? Well, my C effect is going to be equal to AB plus C prime here, okay? And it's important to see sort of how this stuff goes together. So if I've got X and Y, this is my C path right here, right? This is functionally just the correlation between these two variables, right? Within the context of this model, this is all the relation I have to account for. This path right here is going to be equal to my indirect path, AB, plus whatever is left over here. All of that is going to be represented in sort of this sort of original relation between X and Y. Okay. Now determining sort of what the tricky part here is how do we determine whether AB or the reduction of C to C prime, whether or not this is statistically significant, right? And if we need to determine whether or not something's statistically significant, we need to get a standard error for that thing, right? We can't have a statistical test without a standard error. And so what Sobel provided is an equation for our normal theory test of the reduction of C to C prime. So is the product of paths A and B, or the reduction of C prime, however you want to talk about it, is that statistically different than 0? Well, in order to do this, we need to get a standard error. And so Sobel derived a formula for the standard error of AB, or C minus C prime, however you want to talk about it, where your standard error for this indirect path is equal to the square of your coefficient for path B times the standard square of the standard error for path A, plus the square of A path times the square of standard error for B path minus the square of standard error for A times the square of standard error for B. Take the square root of all of that. Okay. Then what we do is we take our AB path, divided by our standard error, and what this gives us is a Z statistic that we then test against sort of our Z cutoff values, right? And this is going to be our test in a partial mediation situation of whether or not this indirect path of A to B is statistically significant. Okay. people have questions about this? All right. McKinnon and Dwyer, later paper, and this starts to be helpful, talking about the magnitude of mediation as the percentage of the total effect accounted for A, B here. And this starts to get tricky. This is one of the things, I was talking with Sean the other day. He put together a paper, and the reviewer was like, you need to have an effect size for your indirect effect. Currently, there are no good effect sizes for indirect effects. They just don't exist. There's a number of metrics that people have calculated, but none of them are very good, right? And none of them are super interpretable. So we haven't progressed enough to get a good standardized metric of effect size for an indirect effect. But one thing you can do from a descriptive standpoint is talk about of the total relationship we see, of the total relation between X and Y, how much of it is being accounted for by this indirect path. And what we're doing here is we're just taking our indirect path, the product of our coefficients A, coefficients B, we're dividing that by AB plus C prime, whatever is left over. And so what we can do is we can interpret that as, we could say, the indirect effect of X on Y through the mediator accounts for 80% of the relation between these two variables or something like that, right? And that seems like a lot. That seems like a pretty good indirect path, right? So again, it's descriptive, but something that could be calculated in these simple mediation effects. Okay. Questions about what we're doing here? Okay. I'm going to walk through an example here. And so grab your handout. In this example, what we've got, we're wanting to know whether or not attitudes towards support utilization account for the relation between PTSD and social support. Okay. So we know, this is another situation. We know that PTSD is related to social support. That's been shown again and again and again and again. If I put together a paper, try to submit a paper, say, hey, PTSD is related to social support, you were going to tell me buzz off, because we already know that, right? But what we might start to ask is why? What's going on? What's accounting for this relation? And so what we might suggest is that we see that PTSD severity is related to social support, maybe because people with PTSD, we know that people who have chronic symptoms tend to look at people, sort of view the world differently, have different perceptions about sort of the utility of sort of what the world, how the world works, and so these fundamental beliefs. And what might happen is I can have all the social support available to me, but if I refuse to engage my social support network, it doesn't matter. My social support will be a billion, but if I don't engage it, if I don't utilize it, if I'm suspicious and don't feel that utilization of support networks is going to be a useful thing for me, then my social support is going to be low, right? And so what I'm thinking here is I want to test is whether or not this utilization construct accounts for the relation between PTSD and reductions in social support. So here we've got support, a continuous indicator of perceived support. Utilization is a continuous indicator of attitudes towards support utilization. It's good to talk with people. I can rely on, I feel comfortable relying on other people if I need something, these types of things. And then PTSD is our continuous indicator of PTSD symptom severity. Okay. So open up your SPSS file. Okay. So first thing we're going to do is we're going to go through and center our data here. So I'm going to go analyze, descriptives, and perceived support is my outcome. So I'm just going to look at support utilization and PTSD. I'll piece this up here. Go through and run this. And it's telling me that compute, I'm going to go call this C PTSD. My center PTSD is going to be PTSD minus, and my value here, my mean, 23.4474. So there's going to be my centered PTSD variable. And then my support utilizations. Lies. My mean conveniently is 46. That's weird. Minus 46. Going to go through, compute my two centered variables. Oops. Whoops. Have to name it something different. There we go. Okay. There I got my two centered variables. You've been doing this for the past 4 weeks. Comfortable centering variables. Cool. Okay. So what I'm going to do now is I might go through now and just check this to make sure I didn't subtract a standard deviation or something like that. That's fine to do. Run this here. Awesome. Mean is 0, center these variables appropriately, feeling good to go. Okay. So, gonna run my model. What's the first, what's the, for my causal steps approach, what do I run in my first model? Neil, what is it?
Just a simple regression. So we'll predict our X or Y.
Y on X, right? So here, my outcome is social support. My predictor is centered PTSD. And so I'm going to hit paste. Methodologists. Okay. Go through and run that. All right. Layla, what does this first regression model tell me? What's that? Well, maybe R squared. Why did I run this model? What am I interested in looking at? Ultimately, that's what I'm getting at. What am I getting at in this first model? It's on your thing too. If you are having a hard time seeing the small stuff.
Yeah.
The other way around. We regress report onto PTSD. Okay. So what is this model telling us? The relation between PTSD and support. And is that statistically significant?
Yes.
Okay. What's that?
So we're regressing Y onto X, right?
Yeah.
So isn't X PTSD?
Did I not regress? Yeah.
X is PTSD, and then Y would be support, and then.
Oh, I got support utilization. Sorry about that. Good catch. Sorry. Grabbed the wrong thing. There we go. Thank you. There we go. Okay. Now we're back in business. All right. So we've got here is we're looking at the relation between X and Y. So which one of these paths are we capturing here? C, okay? So I've gone through and I'm looking and I see that, yes, X is related to Y. My unstandardized coefficient is negative 0.3030. And it's statistically significant. What is it?
0.091.
0.091. So it looks like my PTSD score is accounting for about 90% of the variability in my outcome. Okay, and so my C path here is negative 0.030. Okay, this is the total relation between X and Y that I'm accounting for, right? So my standard coefficient is negative 0.303, so it's sort of a moderate effect. What my unstandardized coefficient is telling me here, that a 1 unit increase in PTSD score is accounting for 0.03 unit, expected 0.03 unit increase in my outcome. That's super small, but my PTSD scale is really big. My social support scale is really small. So this is why looking at my standardized coefficient just gives me a better estimate of sort of kind of the magnitude of this effect. But it's statistically significant. My model is significant. So Haley, what have I concluded based on step 1 of my model?
Well, I have a question.
Yes.
So I did 0.03 squared and I got 0.0009.
Okay, nope, sorry about that. My
30.
unstandardized coefficient is 0.030.
Yes.
My zero
Okay.
correlation is negative 0.303.
Gotcha.
It's tricky. I don't know. So yes, what we would be doing, because we only have one predictor in the model, is we just square my correlation. And we see my zero order, my part, and my partial are all the same value because there's only one thing in there,
Okay.
right? So that's what's going on there. Sorry
Right.
about that. Yeah. So my unstandardized coefficient 0.030, suggesting a 1 unit increase in my PTSD scale, accounting for a 0.03 point unit reduction in my social support. That looks really small, but it's just based on the scaling on my stuff. Okay. So step 1 of my causal model, I've gone through and I've established that yes, there is an association between X and Y to be mediated. Okay. So this is my C path. So Nick, what am I going to do for my next path? What do I need to do here? Yeah. Make sure I do this correctly. So my outcome now is my centered utilization. Okay. So I've got regressing centered utilization, my mediator, onto my predictor. And if I go through and run this, Laura, what am I getting out of this second model? Was it path A? Absolutely. Second model is model 2 is giving us path A. And what are we taking from this regression model here?
So that's it.
Yeah.
Well, it's significant, so that's good. We're seeing that there is a relationship between our predictor X and our mediator.
Mm-hmm.
We also get there. Do you want this number?
What's that?
Do you want the same?
Sure. You go ahead and give me.
0.251.
Okay. So, step 1 of the model gives me the relation between X and Y. Right? As my PTSD goes up, social support goes down. This isn't surprising because I knew that because that's what's been demonstrated in research over and over and over again, right? But it's good to know that in these data I've gone through and established that effect. Second step of the model, I'm regressing my mediator onto my predictor, and it's telling me, Kate, what type of association do I have between my PTSD variable and my utilization of support?
Positive.
Positive. This is a little bit tricky. This utilization measure, higher scores indicate less willingness to utilize support, so it's a little bit tricky. But so as my PTSD severity increases, I become less willing to utilize support. I'm more reluctant to utilize support. Okay. And then we can go through and take a look at our sort of effect sizes for this if we would like. We won't worry about this too much. And so then one more step, John. What do I do with my last step of this model? Or the last step of this, of these analyses?
So we regress your outcome to mediated.
Yeah. And take my outcome variable, which is going to be support, regress it onto my original x variable and my mediator. Okay. So I'm regressing y on my mediator and my x. Okay. I just go through, run this model. And Emilio, what am I getting out of this model?
I'm going to be getting the beta from itself.
What's that?
You're getting, oh, okay, the beta.
Yeah, I'm getting my B path. Okay, and tell me, and what is my B path? -0.084. Okay. What else am I getting out of this model?
That there's a negative relationship.
What's that?
There's a negative relationship between the mediator and the y.
Okay, so as my reluctance to utilize support increases, my perceived support decreases. Good. What's the other coefficient in this model of relevance?
What would be the same?
What's that?
We're going to be looking for the standard error.
Okay, yeah, we're going to get the standard error. What else do we have? What's the other predictor in this model? C prime. Yeah, and what's Laura? What's C prime for in this model?
It is. -0.009.
Yeah. Okay. So what we've gone through this in this basic mediation model, through our three separate models. First model, we regress x onto y or y onto x to get sort of this C path. This is the total relation. This is the total association that we can account for, right? In our second model, we regress our mediator onto our outcome, or our mediator onto our predictor to get path A. This tells us the relation between my predictor and my proposed mediator. And in the last step, I'm taking my outcome, and now I'm regressing it onto my mediator and my x, right? And what I've got here, this gives me path B. It gives me the unique association of my mediator with my outcome, controlling for my original x variable. And then it's also giving me this residual path. It's giving me this what's left over after I account for my mediator, okay? And so, if we go through and we take a look at this, if I want to determine AB, okay? I want to think about AB as my indirect relation, right? Thinking about your indirect relation is just the magnitude of the relation of x on y through m, right? If I take A is 0.251, and I multiply that by -0.084, someone tell me what I get. -0.021. Okay, so this is the coefficient for my indirect path. What if I don't like that though? What if I'm old school? I'm rocking the 80s, right? I don't want to think about this model is telling me the difference between my C and my C prime path, right? So I say C minus C prime is going to be equal to -0.030 minus -0.009. Okay. What do I get if I take C minus C prime?
-0.021.
-0.021, right? It's the same, right? It's the same number, it's the same sort of situation, right? What if I go through and I take AB plus C, if I take negative 0.021 plus C prime is negative 0.009, what do I get? Negative 0.03, right? Which is my original thing up here, right? It all fits together here, right? And so what I can do is I can start to go through and test. Doesn't matter whether or not I want to call this indirect path, if I want to call it AB, or if I want to think about it as the reduction of C to C prime, it's the same stuff, right? Now remember, write this down on your thing that we're always working with our unstandardized coefficients here. You'll screw this up, because I did it, everybody does it, and you start sort of multiplying your standardized coefficients, and then things are going to go astray quickly with that. Always working with our unstandardized coefficients with this, okay? So here, I've gone through, and is my residual path statistically significant in my third model here? No, it's not, right? But maybe what I want to do is I just want to go through and double check, and I want to test the statistical significance of my AB path, right? Technically, from an old school Judd and Kenny, I can claim mediation because I've gone from a statistically significant path to a non-statistically significant path. I can claim full mediation. But I just want to be conservative. I want to go through and get a statistical test of AB or C minus C prime, however I want to think about it, right? So now remember, with my Sobel, standard error of AB is going to be equal to the square root of B squared times standard error of A squared plus A squared times standard error of B squared minus standard error of A squared times standard error of B squared. That's a lot of stuff. But luckily, SPSS is giving all this to us within the context of our output. So we're going to see square root of negative 0.084 squared times 0.030 squared, right? Because again, if we take a look at our that's not right. B squared. Oh, yeah, it is. I have to go back to my other model. So I got sort of my B, the coefficient for my path B, 0.084. Then I kick back to model 2 because I have to, or model 2 because I gotta get the standard error of A is 0.030. See that? Okay. So I've got that plus my A path 0.251 squared times standard error for path B 0.009 squared minus 0.030 squared times 0.009 squared. Okay. You see where I'm getting these numbers from? Okay. And be careful. We're multiplying a lot of decimals in your calculator. Make sure that you're not sort of just rounding to the nearest whole number and things like that, because you're going to be way off base with stuff. But if we go through and we run this out, what we're going to get is 0.0034. And this is going to be the standard error for my AB path as calculated through my Sobel test. Okay? So now what we need to do is we need to calculate our test statistic. So our Z coefficient, remember, is going to be my AB path. So negative 0.021 divided by standard error I've derived, 0.0034. What do I get? What's that?
Negative 6.166.
Is that right? Yeah. Negative 6.176. Right. Yeah. What is that statistically significant Z? Yeah, that's a decent Z score, right? So we would say that this is my indirect effect of X on Y through my mediator. My AB path or my AB coefficient is statistically significant based on my sub-L test here. Okay. Last thing I could do, if I want to calculate percent mediation, right? I can take my AB path, it's going to be 0.021, divided by my total, 0.030. Okay. So you can give me 0.70. So what I could say here is I could say 70% of the association between AB is accounted for by the indirect effect through support utilization. I'd say 70% of the association between PTSD and social support is accounted for by the indirect relation through reluctance to utilize support networks and things like that, right? When I'm talking about these, I'll often talk about these effects as the indirect effect of X on Y through M, right? So this is the indirect effect of PTSD symptom severity on perceived support through support utilization, or beliefs about support utilization, or something along those lines, to capture that what we're talking about is this AB path here. Okay. Questions on this? And that's it. Pretty simple, right? And if I've got a simple mediation model, these are not too difficult to test. It's all pretty straightforward. It's just basically taking some stuff and going through and calculating things. Pretty easy peasy. Who likes this better than moderation? Yeah, ends up being a little bit easier to manage and work with. Okay. Questions on this? Yes.
So that, like, where you got like the 70%, is that just AB over C?
Yeah.
Okay.
Yeah. Or AB, in the slide, it's AB over AB plus C prime, but that's just C anyway,
Oh, okay.
right? So again, thinking about things in terms of ratios, right? This is just a part over total, right? So of all the association that we see between X and Y, how much of that is accounted for by the indirect relationship? And so we can go through and calculate that. And this is a nice, it's not a perfect effect size, but it sort of gives you a general sense of how much of this is being accounted for. And it's pretty big, and that's kind of what we would expect, given that our statistically significant effect here completely went away once we accounted for support utilization, willingness to engage support systems, right? So feeling pretty good about this. Okay. So let's go through and then talk about some stuff that now then starts to make this kind of conceptually complicated. Okay. So we've got a decent system here. We like it. It makes some intuitive sense. The problem is with our causal step models is we have some conceptual limitations, some statistical, some mathematical limitations that we need to go through and account for. First thing is causality, right? We're calling this our causal steps approach, right? But our causal steps approach in and of themselves aren't sufficient to establish causal relations among anything, right? Best case scenario, right? I've measured X at time 1, mediator at time 2, Y at time 3. Best case scenario, temporally spaced, done enough to establish that X causes Y, so on and so forth, right? We talk about it in that way, but it's not enough, and so we start to get, there's problems in terms of trying to talk about this in terms of a causal situation. If we've got an experimental design, right? Experimental designs, much more rigorous tests of some of these mediation processes. If I can randomize things here, then sort of keep everything controlled, and then measure something here, and then measure something on the outset, I can control for external factors. I can manipulate my hypothesized mediator. I have better control over things within the context of an experimental setting, and so that helps, right? But still, even if you're an experimental person, you start talking about cause, you're probably going to run up against difficulties. People give you grief about that, right? If you're one of us clinical people, I can't experimentally manipulate PTSD or eating pathology or substance use or any other such thing, right? And we're really stuck with correlational analyses, right? And it can start to be, these models are easy to analyze, much more difficult to defend than a moderation, okay? What I can do is I can get some longitudinal assessment as to establish some temporal precedence, right? So I've measured this at time 1 and this at time 2, which kind of eliminates the possibility that my mediator is actually driving my X value. Well, it doesn't completely get it taken away, but I can at least sort of start to space these out temporally, right? Temporal sort of precedence isn't enough to establish causality, but it helps at least a little bit in terms of making our arguments. But again, we have to start to be careful about how we're talking about this in correlational data, particularly when we're working with cross-sectional data. I'll often talk about these as intervening variable models and sort of variables accounting for a relation between X and Y as opposed to using causal language. People tend to be sort of more okay with that. But if you've got cross-sectional data where everything is measured at the same time, and Emilio said, hey, this is the model, I'm going to ask him, why not YXM or MYX? Why not some other? If I can take your variables, put them in a bag, jumble them up, and come up with an equally plausible model, your mediation model is very compelling, right? So this is where we need to start relying on theory, existing evidence, things along those lines to really make a strong case from a conceptual standpoint that yes, this is a plausible model. This is why we put these variables in this order. Okay. So we've got some. It's called the causal model. It's called the causal steps approach, but it's not actually any. There's nothing in there that actually establishes any type of causality. We also have this concern with our causal steps approach, or we're saying that X and Y need to be related to one another. We need to have an initial relation between X and Y before we can proceed with our causal models, because if X and Y aren't related to one another, then why are we talking about mediation in an association that doesn't exist, right? Which makes some conceptual sense, or sort of intuitive sense, right? But conceptually, mathematically, we've got some issues with this, okay? Now, if X and Y are related to one another, or sort of are measured close in time to one another, then we probably should see a relation between X and Y. If I measure your mood right now and your mood or some other thing 5 minutes from now, I should probably see a relation right there if I'm trying to talk about mediators, right? But as our assessments start to become farther and farther apart, we can start to see the relation between X and Y start to become attenuated due to a lot of different things, right? There's other stuff that can go through and start to, even if X and Y do hold a relation, the more time there is between those assessments, the more time there is for other stuff to start to go in and start to influence that relation. right? I've got competing processes that can start to come through. I can start to have random error come through, and so as I start to, as the amount of time between the relation between X and Y starts to increase, I'm just opening the door for all sorts of things to start to go through and play in, right? So Shearer's dissertation, taking some secondary data, looking at health-related outcomes, looking at depression and substance use over like 10-year period, right, with sort of big sort of grant-funded stuff. And we don't have a really strong association. These are two things that we know are fairly strongly associated with one another, but over the course of 10 years, that association starts to drop, right? Just because there's a lot of stuff going on in there. And so what we might find is even if I have a good argument for why X and Y are related, and I have good empirical evidence that X and Y hold an association, if these two things are measured very, very far apart in time, particularly if I have a small sample, I might not find a statistically significant association between there, okay? And in some cases, what I might run into is sort of an issue of statistical power to detect this initial relationship. So let's say in this situation, my path A is associated with a medium effect, say a correlation of 0.3 here, and my B path is associated with 0.3, right? So if I've got a medium effect for my path A and a medium effect for my path B, a sample of 20 people, or excuse me, a sample of 80 people gives me enough power in my sample to detect the statistical significance of this and the statistical significance of this, okay? But if my A path is 0.3 and my B path is 0.3, if I multiply those two things together, what's my C path? What is it? 0.09, right? Because if this is complete mediation, right, there is no relation between X and Y after I account for the mediator. But my A path has a sort of a medium effect. My B path has a medium effect. My effective C is the product of these two, right? And in order to detect even 100% mediation, my C path then is expected to only have a value of 0.09, and now I need 1,000 people to detect sort of that base relation I'm looking for, right? And so what we can find is a really strong effect here, a really strong effect here, but remembering that if this mediator is the one thing that accounts for all the variability, my C path is the product of these two things. So a medium effect and medium effect, multiply those together gives me a really small effect. Now I need 1,000 people just to test to see if there's a relation between A and Y, right? So even though in the population, yes, this is a correct model, I have nowhere near enough power to detect that base relation if I have a full mediation there, right? And so this starts to become problematic. People see sort of conceptually what can happen with some of this stuff. Other thing, paper by Shrout and Bolger, and again, you guys are busy. I'm not going to ask you about this stuff, but do go through and read these papers. These are just really, really good conceptual papers on how to think about some of this stuff. One of the things that Shrout and Bolger note is that we can have suppressor effects. Now, not suppressor effects like Tabachik-Padel, Bell-Dancing nonsense suppressor effects, but what can happen is if I start getting residual effects that are equal in size but opposite in value to my indirect effect, what I can have is things that start to cancel each other out, okay? So let's say I have a case where coping behavior is my mediator, okay? And environmental stress is my X, and psychological distress is my outcome, okay? In this situation, I expect as environmental stress increases, coping behavior will increase. As my stress levels increase, I increase my coping behavior. So I've got a positive association between X and my mediator. A has a positive association. And I would also expect that as my coping increases, I would expect my negative psychological stress to go down, right? Coping increases, stress goes down, right? So I expect B to have a negative association. So Nick, what's the valence of my indirect path here? If I take a positive effect, multiply it by a negative effect, what's my AB path? negative. It's going to be a negative path, right? Well, what I might find is that if the residual relation between X and Y, this is psychological or environmental stress and psychological distress. What's the relation between environmental stress and psychological stress supposed to be? Positive, right? If my indirect path, if I got partial mediation through coping, it's about, if my AB path is about the same strength as my residual XY left over, right? Remember that C is equal to AB plus C prime. If AB ends up being negative 0.3 and C prime is equal to positive 0.3, what's the relation between X and Y? What's my C value? 0, right? So I don't find a relation. X and Y look to be orthogonal to one another, which really confuses me, right? Well, what might be going on is I've got a positive, so the value of my indirect path is negative, because I've got a negative relation times a positive relation, is that right? Or a positive relation times a negative relation. My residual stuff that's left over is negative or positive, and so what ends up happening is just mathematically, it looks like I have no association there, and so then I say, well, I guess nothing to see here going forward, right? This would be a curious situation, but what we could have is that my indirect effect cancels out my residual effect, resulting in a 0 path. So again, what we might find is no relation between X and Y, or something that looks like no relation between X and Y, okay? If we have run into a situation like this, we could make an argument for continuing to evaluate this indirect path, even though I don't have a base association here, because I could make an argument like, well, sort of mathematically, this is what's going on with stuff. Okay. So again, just another example of why this hard and fast rule on we need to have a relation between X and Y starts to become problematic in some situations. So situations where you might want to think flexibly and sort of understand if you fail to establish a relation between X and Y, think about why that might be. Okay. So yeah, these suppressor effects we're talking about here are different than other types of suppressor effects. It's just sort of an artifact of your individual paths that go through and cancel this relation out, even though X and Y are certainly related, both through the indirect effect and through the residual effect. It's just the omnibus effect is being masked by that. So in thinking about this stuff, people love mediation models because see, this is the mechanism. This is why X and Y are related to one another, right? These are easy modelers to take a look at, sort of less complicated, less work than our moderation, but much, much more difficult to defend conceptually and provide a credible account of, yes, this is actually what's going on. If your strongest situation is going to be if you have an a priori effect of X on Y, having a base relation there is going to be easiest to go through and proceed with your model, right? Having this relation between X and Y is conceptually useful, provides a more compelling case for that sort of, yes, there's an association there to be mediated. But we can start to relax this assumption of this a priori assumption of association with X and Y in situations where if I've got my X and my Y are being sort of measured very distant in time, right? I might make an argument, came up in Adam's thesis, right? We went through and we screened PTSD in our in the screener, and then assessed some anger-related stuff in an experimental sort of situation at some point during the semester, right? So we could have months between someone's when we assess their PTSD symptoms and when we actually sort of engage in an experimental test to represent anger, right? And what we found wasn't a real strong effect there, right? But talking about, so basically what we've done is these measurements were taken very far in time. All the stuff that relates PTSD to anger is all cross-sectional stuff. And so we're making the argument that that's why we're probably not getting as strong as effect as we might see sort of relative to the other literature, right? We can also start to relax this case if we have subtle effects, right? So this starts to go, what I'm expecting is sort of modest relation here, modest relation here. If I've got complete mediation, that means that the relation between X and Y is really small. I can't capture 1,000 people to sort of get this, but if I can make a strong argument based on existing research, this is about the effect I would expect here, this is about the effect I would expect here, assuming that this is the association I would expect between these two variables, and trying to go through naked arguments there. Or if I expect some sort of suppressor process where my indirect relation is of opposite sign and equal magnitude to my residual effect that's left over, again, talking about that as maybe a situation where I might still want to proceed with my mediation analyses, even in the absence of an association here. But again, this starts to be incumbent on you to provide a reasonable and compelling rationale for why you're looking at mediation, even when there's no when it appears that there's no association to be mediated at all. Okay. Questions on this? Okay. Other thing that goes on, we've got a problem with our standard errors, right? Standard errors is the bane of our existence. We love to meet them, but they also give us fits, okay? This Sobel test for testing classic approach to mediation, or Sobel-based standard errors, they're not an appropriate standard error for this effect that we've got going on, okay? Someone tell me, someone sort of just make my friggin' year and tell me what a standard error is. What's that?
The variance we expect, like one, mean of one. We call it like mean of one distribution of variance. Let's say that.
Yeah. Were you gonna add something, John?
This is just a standard deviation of the distribution.
Okay, so you guys just.
This would be average amount of error we'd expect from one application to
Oh,
the
yeah,
next.
It's my heart that she's like Grinch got huge, right? Yeah, absolutely, right? So if we're thinking about the standard error of our AB effect, right? Our standard error is telling us if we were to replicate AB over and over and over and over and over again with resampling from sort of the original population, what would the distribution of that statistic be, right? And what we've done with Sobel is we're using normal theory to go through and say, well, if this is sort of and again, our standard error is going to be, functionally our standard error is the standard deviation of our sampling distribution, right? So if this is our sampling distribution of some measure, if we're looking at sampling distribution of the mean, sampling distribution of the mean is perfectly normal, right? If I were to sample all samples, all possible samples of size 100 from the population and look at the mean over all those samples, I would get a beautiful normal curve, right? And so my standard error of the mean is going to be the standard deviation of the expected, on average, the expected deviation from any two randomly generated samples, or any deviation from any individual sample from the mean of the distribution of sample means, right? The problem is the sampling distribution of AB isn't normal, okay? And so what ends up happening is if we apply a normal theory to a sampling distribution that's not normal, our standard error isn't precise, okay? So if I go through, in this example, and I were to go through and sample, run this study, and then replicate it 5,000 times, what I would find is the standard, or is the distribution of my AB effect, it's not going to be normally distributed. It's going to be skewed, right? And if I have a positive indirect effect, I'm going to have a positive skew. Here, I have a negative indirect effect, it's going to have negative skew. And so Sobel assumes that this is the standard deviation. This is sort of average difference this way, that way, right? It's a normal theory test, but we're applying a normal theory test to a statistic that doesn't have a normal distribution. And so Sobel provides an approximation of our standard error, but it's not exact. And what ends up happening is I end up with my z-test here, calculated using my Sobel, my test is underpowered. I have inflated type 2 error in cases, except unless I'm working with really large samples or I have really large effect sizes, my Sobel test is not going to be sensitive. It's going to reject. It's going to reject. It's going to fail to reject the null more often than it should. Okay. So my Sobel test is underpowered. Is it not sort of doing? So it's an approximation. And so in the 80s, it was sort of a theory that we used to derive this assumes a normal distribution, but our distribution of AB isn't normal, it's skewed, and so it ends up being off. And the practical consequence is that we're failing to reject more often than we should, right? We're not detecting the stuff that's there, so we've got problems with type 2 error. People sort of seeing at this point sort of understand kind of the problems with Sobel and what's happening with this. Okay. And so, again, there's been some improvements on Sobel to try and address the non-normality in the sampling distribution of our indirect effects, but we still have problems, and sort of our confidence intervals based on Sobel still performing poorly. And so, what we've got, we're generally not working with large sample sizes in psychological statistics, and we're almost never working with large effect sizes. So this ends up being kind of a serious concern. So what we can do now with the power of technology is rely on some bootstrapping techniques. Did we talk about bootstrapping before? Okay. Bootstrapping, what we're doing with bootstrapping is going to be a resampling procedure where we go through and we generate our own empirical distribution of some type of parameter based on the data that we have available to us, okay? And our bootstrapping procedures that we have available now through some different macros, these are our best practice approaches for looking at different mediation effects. So what we do with a bootstrap sample, so our NOS, or our example here, what we would do, we take our original set of, how many people we have in this set? A little over 300. Take our set of 300 cases, right? And what we do is we go through and draw 300 and, let's say, what, 304 people in this sample. Take my 304 people, use that as my population. And what I would do is I would go through and randomly pull, with replacement, a new sample of 304 individuals from my original sample of 304 people, okay? How is this bootstrap sample of 304 people different than the one I'm looking at right now? If I'm drawing with the replacement, am I going to get a different sample than what I'm looking at?
You probably have repeated.
Yeah, I'm going to have people who are in my sample over and over again, right? So I've got my sample of, well, let's just call it 300 people, right? I've got my sample of 300. And what I'm going to do is I'm going to draw a bootstrap sample of 300 cases with replacement, right? And then what I'm going to do is I'm going to evaluate with those 300 cases that I've got, I'm going to go through and I'm going to estimate AB, right? So I'm going to run this analysis and I'm going to calculate AB. And then I'm going to do this steps 1 and 2 again for, like, say 500 times or 5,000 times. So I'm going to, from my original sample of 300, I'm going to draw 5,000 samples, 5,000 bootstrap samples with replacement from this original sample of 300, okay? Will those samples be different? Will those 5,000 samples be different than one another? Yeah, slightly. If I'm sampling with replacement, right? I don't know, I may have sort of, I get one sample and Kate's in there 400 times, right? Just because you just happen to come up, right? Or we have another sample and you don't come up in there any times, right? And so what we've got with this bootstrap procedure, we go through, we draw a sample of the same size of our, using our data, we go through and draw a sample of 300 people. We go through, we run our tests, and then we do it again. And and then we do it again, and we do it again, and we do it again. And eventually what we get, after 5,000 redraws, is what we can do is we can take my A/B coefficient for each one of those 5,000 analyses, and I can plot those out, okay? And when I go through and I do, now what I've got is I've got a distribution of A/B that I can go through and I can use that then to calculate my standard error. Because remember, my standard error is just the standard deviation of my sampling distribution. So what I do is I create my own sampling distribution based on the data that I have, drawing samples with replacement, and then what I can go through is I can go through and I, based on my empirical distribution, I can then create my own standard errors and my own confidence intervals based on my empirical distribution and account for the asymmetry of that sampling distribution based on the data that I've created. Okay? There's some stuff that we can do, some different tweaks on this, a bias-corrected bootstrap that simulation studies are currently identifying as sort of best practice for this stuff. Okay. Questions about what we're doing with this bootstrapped situation? So just to give you an idea, right? If this is the distribution of AB, right? If I went through, from my sample of 300, and I went through and I randomly sampled 5,000 samples of size 300 from my original 300 people, but each one of those samples is going to be slightly different than the previous one, right? They're all going to be a little bit different, and if I go through and I calculate and run my NOS, or run my mediation model in each one of those 5,000 samples, I'm going to get 5,000 values for AB, right? And then if I go through and I plot those out, now I'm not having to work with normal theory. I have my own sampling distribution. I know what the sampling distribution of AB is, right? And so what I can do is then I can use that and use some sort of calculations to go through and derive a standard error based on my observed sampling distribution for my bootstrapped effects. That way I don't have to worry about the assumption of a normal distribution when I know for a fact it's not normal to begin with. Okay? And what we end up with is a much better approach to going through and running our stuff. Okay? Now this would be a hard thing to do if you then had to go through and run this model and calculate your indirect effects 5,000 times. Luckily, you don't need to do that. Okay? Andrew Hayes put together a macro for SAS and SPSS that does this very well. This is a very, very useful tool. People are starting to get a little out of control with it because they don't understand exactly what it does or doesn't do. But the idea here is this is a macro that we can run in SPSS. And once you load up that macro, you can, with a very simple model, go through and start running your evaluation of indirect effects using your bootstrap standard errors. Okay? For our macro for mediation, the command to run this model is simple. You go process vars equals your variables included in your model. This is going to be support, utilization, PTSD. My Y is support, my X is PTSD, my moderator is utilization, and then I'm telling process to run model for. In the handouts that you got on the course website, you'll see a PDF that says templates. And this is just for this version of process that I gave you the macro for, gives you, what's this model represent? This is a moderation model. You can run moderation in process as well, right? So we got moderation. Here we've got a two-way interaction or a three-way interaction of M and W and X on Y, right? Here's our mediation model. This is our simple mediation model that we're running. And then if we go down through, there's all sorts of crazy different complicated models. And it's nice if you say, oh, I want to run model 11, these are my variables, you just plug it all in there, okay? So, some additional options with mediation, some bootstrap stuff, confidence intervals, some things here that we're not going to worry about right now. will you guys give me like 10 minutes over, we can work through sort of that mediation stuff and then be sort of finished with this? If you need to get somewhere, sort of certainly go, just want to finish this up, it won't take much. So if we, let's go through, and if we go to your PTSD, the data here that you've collected, if you go through and we open up this Haze macro, okay. This is a big, massive mess of a file, right? That seems like a ton of stuff that we don't want to worry about, right? But all you need to do is take it and highlight all this stuff that they've written. It's going slower than I'd expected. Frames. This is going faster on my computer. Elevate the music or something. Okay. So we've highlighted this whole macro, right? And then all you need to do once you highlighted the macro, if you don't have anything else on there, you can just hit Control A, just highlight it, select all, and then run it. But if we go through and rerun it, it's going to go through. Oh, you bastard. There we go. I'm going to do this. That's easier. Okay, hoping that this better work. All right, so what we've gone through and highlighted this macro and run the macro. That should load the macro, and now SPSS is ready to read your output, right? And so what we can do now is I can go through and just in my syntax file, just enter this command, right? So I've got process varies is equals support utilization PTSD, Y is support, X is PTSD, M is utilization, total equals 1. I'm asking for total effects. This is also on your handout. Last sheet of your handout, you can take a look at that. Normal is normal theory, effect size, bootstraps. If I go through and I take this and I run this, all right, well, this is being garbage. Something's going on. But if I go and I run this model, what it will give me is, did anybody get that to run? This is the thing. So this is an old version of process that worked with the new version. In order to run it and get the commands, you have to buy the book. And so this is an old version. Is it, Amelia, is it not working on yours? Okay. We'll go through and see if this, it runs on my computer with my old hacked version of SPSS. I don't know how to disable it or something like that. But anyway, did it work for you? Okay, cool. So it's working. If we were to go through and run it, again, we've got process equals support utilization PTSD. Here's my model that I'm running after I've loaded the macro. What this does is this will go through and run your model in a sequence of steps, okay? So the first so in your output that you would get, and again, if you take a look at your last page of your handout, this is going to give you your output that you get. This, did you do this? Okay, cool. Something's going on with this, it sort of hiccuped, but just to walk you through what's going on. So we got the output is running model 4, your Y variable is support, your X variable is PTSD, your mediator is utilization, sample size 304. Is this what we wanted to do? This is what we wanted to do. Everything's looking pretty good, right? What we've got, and then so in each one of these steps you can go through and take a look, and you can see that it's giving you model, okay? First one here, my outcome is utilization. My predictor is PTSD. This is giving me path A, right? And if I take a look at my coefficient that I got in SPSS when I ran this manually, my coefficient for path A, 2.251, it's the same thing I've got here, right? Basically, process isn't doing anything different than you have already done in SPSS anyway, right? In the second section here, my outcome is support. My predictors are utilization and PTSD. This is the model that's giving me path B and path C prime, right? And again, if I go through and I take a look at my effects, utilization, negative 0.084, negative 0.084, PTSD, negative 0.009, 009. It just ran sort of my third model here. And then here, my total effects model, it's giving me my outcome is support, my predictor is PTSD. It's just giving my C path right here, right? If I go down through and look, my coefficient 0.030, same thing we've got going on there, right? So basically what process did is it just ran my 3 models, it just sort of ran them for me, right? But then what we can see is my total indirect and indirect effects here. What this is giving me is so my total effect of X on Y, this is just my C path, okay? My direct effect of X on Y, this is my C prime, okay? And then what I've got here is my indirect effect of X on Y. This right here is really the only thing that process is giving to you that's different at this point than anything else that you ran by hand. What process is doing is it's giving you your indirect effect of X on Y. And this is negative 0.021. This is the same thing we calculated here. Again, this is just giving you the indirect path. But what process is doing is it's giving you a bootstrapped confidence interval for this indirect effect. So after it's gone through and ran 5,000 bootstrap replications, each one of these bootstrap replications calculating a B path, what it's done is it's gone through and created a confidence interval based on that empirical distribution, giving you a lower limit and an upper limit, a 95% of a 95% confidence interval, where my lower limit for my AB path is negative 0.028, upper limit negative 0.015. What do we conclude based on that confidence interval? Do I have a statistically significant indirect effect? Yeah, why, Laura? Because it doesn't include 0, right? And so what process has done is it's gone through and circumnavigated sort of this Sabel test by going through and creating an empirical distribution, giving me a 95% confidence interval around my AB path that's methodologically better estimate for the statistical significance of AB than the Sabel stuff, okay? Now, if I were to run this again, would I get the same upper and lower limits? Why not?
Because you're no different sample.
Yeah, it's because I'm going to have a slightly different distribution with a new set of 5,000 samples, right? And so every time I run this, you should expect to see slight variations in the upper and lower limit of your 95% confidence interval, right? Will your indirect effect, will your AB effect change? Nope. No, and you're correct again, why not?
Because regardless of like the, can you put it back? The width, what's that word, guys? Yes.
Okay.
Because you're doing a replacement, so then the relationship doesn't have that much of an impact because it's the same set of people.
Okay, you're kind of right on that, but really, so this effect right here, your indirect effect, this is just AB from your data that you've collected. So it's always going to be AB. That's still your best effect, right? So AB, the only thing that you're getting here from process is a bootstrap standard error and your upper and lower limits on your confidence stuff. Everything else is just the same stuff that you calculated with your causal steps. It's just this confidence interval that's giving you a better estimate of the statistical significance. And this is different metrics of effect size. They're of questionable use, and sort of there are different things that people have tried. They're not sort of, any of them are super good. Down here, the normal theory tests, this is just your Sabel, okay? Process just gave you your Sabel test down here, so you compare the results of your Sabel test to your confidence intervals up here, and then down here it's just telling you how many bootstrap replications it ran, your 95%, what level of confidence interval you ran off of that, and that's your process stuff, okay? So this is a nice way of going through and addressing some of the limitations of your causal steps stuff, at least in terms of testing whether or not you sort of partial mediation is statistically significant, okay? Other things you can go through and take a look at in process, you can do like higher order interactions, three-way interactions, mediation with covariates, multiple mediators, right? You can look at moderated mediation, mediated moderation. There's a lot of different stuff that you can do within the context of this macro. Again, the version that I gave you to use is an old version. It's a free one. It should still work. So when you get there, we'll talk about whether or not it. Otherwise, you have to buy it both to get the specific commands to go through and do it. And this is just kind of an introduction to let you sort of familiarize you with process and what's going on with stuff. Okay. In terms of reporting in your regression models, it doesn't matter whether moderated mediation, moderation mediation, just standard regression stuff. Things that you should be thinking about reporting in publications, in theses, dissertations, means and standard deviations. Please, please, please always provide your means and standard deviations. If you're going to include correlations in some sort of appendices or things along those lines, your model R squared, your standardized coefficients. These are a nice way to go through and just look at sort of the relative strength of your different predictors. These are nice things to have in the text because I can look at a standardized coefficient and tell whether or not it's sort of relative to the magnitude of stuff. Unstandardized coefficients, these are important for telling you about unit change in X versus expected change in Y given a change in X. Also remember that standardized coefficients are nice for comparing variables within a model, but if Haley runs a study and then I run a study, my standardized coefficients for those two studies aren't comparable because my data could have different variability. This is where my unstandardized effects start to become important to go through and take a look at. Confidence intervals for your unstandardized effects, and then metrics of effect size. Talk about your squared semi-partial correlations. These are nice because they have intuitive meaning. I can say this variable accounts for X% of the total variability in my outcome. That means some stuff to people, right? But also consider including an F-squared statistic in a table or something like that. That's a metric that can be used to calculate subsequent power analyses. Other thing too, you could report a partial correlation. But your partial correlations are going to be I tried this, your partial correlations are going to be very, very similar in magnitude to your standardized coefficients. And so then it feels like you're reporting really redundant stuff. So what you might want to do then in terms of providing an effect size that people can determine in small, medium, and large, facilitate future power analyses and things like that. In text, if you want to report semi-partial correlations, that's awesome. In tables, F-squareds, statistics, just so people know the magnitude of effect. It's kind of a nice thing to do. Okay. All right. That's it, folks. Thank you. 3 minutes over, not 10 minutes over, so that was good. So we'll go through, I'll get